Gurveep?
Yes, sir.
ಹಲೋ ಗುರುದೀಪ್,
Yes, sir. Sir.
ನಿಮ್ ಬೇರೆಯವರಿಗೆಲ್ಲ ಜಾಯ್ನ್ ಆಗಿ ಕೇಳ್ಬಿಡಪ್ಪ. ಆಸ್ಕ್ ದೆಮ್ ಟು ಜಾಯ್ನ್ ಗುರುದೀಪ್. Yes, yeah, I think, let's start. Akshay, Amen. Good afternoon to all.
Good afternoon, sir.
Yeah, good afternoon. Yeah. What about others? Where they are still? I know it's already 2 o'clock. Not yet joined. It's at only 12 students are joined here. Okay. So in the last class, what we discussed, there were this one, the last class, the measurement of distance using the tape along with the horizontal planes and slopes, direct ranging. These things we discussed there. Setting out the perpendiculars, use of crash tabs and optical squares. Is it?
Yes, sir.
Okay, okay. Right. So that is the first experiment, measurement of distance using the tape along with the horizontal planes. How we are going to measure the distance, horizontal plane as well as in the slope. Okay, and also with the direct rangings. So and what are the so the setting of the perpendiculars using the cross staffs. Okay, and also using the optical squares. So these are all the things which we discussed in the last class. I think yours is a batch one. Horizontal distance reaching the top and bearings. Yeah. Yes. Horizontal plane and instruments, rods, yeah, and fixes. Yeah. Okay. Okay. So in this class, we are going to discuss about the the second one, that is called measurement of bearings. How we are going to measure the bearings and the or the directions using the compass, prismatic compass. Okay, and also how you are going to setting out geometrical figures using the prismatic compass or maybe the compass. Generally, a Brenton compass will be there. Different types of compass will be there. Okay, there is a prismatic compass, Brenton compass, and also survey the normal compass also you can see that. And even in your mobile also there are some the compass like you may not measure the the exactly the the bearings, but you can get approximate one. Okay, and yeah, this class we are going to study the discuss about the measurement of bearings, nothing but directions. You can measure with quadrangle, or you can measure with a whole circle bearing, WCB. Okay, there are different ways of measuring the uh, bearings. Okay, right, and when we are going to measure this type of the measurement, so when you are doing the survey, especially for pipeline survey, road survey, or when you are not using the optical, especially your what you call theodolite, and also your is that total stations, when you are using the tape with the compass, that time only you are going to take the bearings. Otherwise, when you are going to use the total decision, no need all these things, no need of prismatic compass, no need of your taking the bearings, everything it will be inbuilt. Okay, just you need to download the the data, and you can start do the interpretations. That is the part will be there, but in the basic component, how we are going to take the bearings from the compass. From this also you can complete the survey, but it takes time to complete the task. And also it is generally nobody is using for the very big project. Okay, right, and yeah, this is how you are going to set out the geometrical figures. What are those geometrical figures? Geometrical figures are those which are you can divide the area such a way that easily you can easy to do the calculations or area calculation. Say for example, say if your area is say 100 meter by 100 meter, so how we are going to calculate this? So you, for that you can do somehow with a triangle, somehow with a rectangle, somehow with a within that areas you can setting out the different figures, geometrical figures, so that easy for you to calculate. Or you can directly calculate with a if it comes in a square, or if it comes what you call this rectangular, you can directly measure it. That is also there. So generally, to any software which is going to do any the 3D modeling, no 3D modeling, used to take a trigonometric, especially the triangular shape. That is called a TIN, triangular irregular network, triangulation irregular network, like that. So that is called your 3D models, right? Then digital elevation models, wireframes, okay, all these things through the geometrical figures. And okay, and generally we are not using the whole area in one block, so we are dividing that, different segments and different, geometrical figures. Generally used to, it is to take any software, if you can take it as, your AutoCAD latest version of which is using the, what you call this 3D model and everything, SketchUp, and even for the any GS softwares, any 3D modeling softwares, if you take it, it will take it as a, what you call this triangulation network. This is how it's going to divide it, and it's going to give the volume of that. And also it can create the elevation models, terrain models, using those things, right? Let's go to the, the bearing of, measurement of bearings, how we are going to take the bearings, right? And directions using the prismatic compass. And right. This is a very simple experiments which you can easily execute in the field itself, okay, when you come back to the college, right? So let's have a, theory part, and we'll have a discussion how it is working in the field, how we are going to set out the, the, what you call uh, the setup of the, what you call this compass, right? Yes, measurement of bearings or direction using the prismatic compass, and also setting out the geometrical figures. So what is a compass? First of all, you need to understand it is a portable compass which you can keep, which you can use by keeping the palm or hand instrument. It's a handy instrument, it's just like your GPS, okay? Instruments, or temporarily you can fix on the tripod also if you want. Generally, nobody will, do that. But when you every each and every point, if you are going to change the things again, it's very difficult to do the centering, the bubbling bubbles in the center. That's a difficult part. But when you hold on the hand, and again it will be shaking, it's difficult again. So which one is convenient, you can go ahead with this, okay? Where there is a area is completely undulating topography, it's a very steep slopes, that time we can use it, keep the instrument, the prismatic compass on your hand. Otherwise, if it is a flat land, you can go ahead with the hand as well as your tripod, okay? The another big headache is you have to carry the tripod along with you wherever you go, if you are going to survey with the tripod, fixing the compass, okay? So here the magnetic needle of prismatic compass is attached to a circular ring. That is, the magnetic needle will be there in the inside that, and this needle is made up of non-magnetic materials, right? So generally the compass is made of the aluminum, the needle is made of the aluminum, okay? And which moves itself on a power direction, towards a line which pass through the object's van, that we call as van, and eye is slit is known as a line sight. There will be different parts of the prismatic compass. We will have the discussion on that now. The readings of the prismatic compass is 0 degree at south and 180 degree at the north. The west directions were 90 and 270 in the west direction shows 90 degree and 270 degrees. So here is the angle measurement in case of prismatic compass varying 0 to 90 degrees, right? So here is the the prismatic compass. There are different parts of prismatic compass. Box, you can get the box, counterweight, van, and sight van there, and pivot and glass tops, and also there will be metal pin, okay, circular graduated, that one, okay? That is the thing, right? And when it comes to the the how you are going to adjustment in a prismatic compass, so there are some temporary adjustment. You can do it at the field itself when you are doing the profiling, or maybe alignment, taking the bearings, okay? First you have to do the centering. If you have the tripod, first you have to fix the tripod, then after, on the tripod you can fix this the prismatic compass. So the prismatic compass, there are some bubbles will be there in the center of that, and that we need to keep it in center. That's called a centering. And leveling, you have to do it, the tripod if you have keep that, and for focusing the prisms. These three things we need to adjust with the temporary adjustment, right? And that's a centering, and it's a process to set up the tripod leg, such as instruments comes over the center of the object stations. Centering of the prismatic compass is done with the help of plumb knob that we told you, that we discussed in the first classes. What is the use of the plumb bob? Okay, to make the centering of any instruments, even if you are going to make the what you call your there will be a laser light for this focusing light, especially for this total session. But for this prismatic, the prismatic compass and all, it is not be there light, but you have to use the plumb knob. Even for plumb bob, you are using for the plane table surveying also, right? So here is the leveling. We use the prismatic compass as a handy instrument, or you can use it a fixing on the tripod. Okay, so we keep the compass form and levelings and prismatic compass done by leveling with the help of ball and socket arrangements, those things, right? And how we are going to focus it? We focusing the prism of prismatic compass, such as hair of object van should be clear visible, and also reading the graduated circle disc inside the compass, right? And yeah, here is the some of the the prismatic compass and the surveyor compass. There will be a little bit the variations and distinguish. Okay, so in the magnetic needle, so here in the prismatic compass, needle is broad needle type, and but it is does not act as an index. But whereas in the needle of edge bar type, and it also acts as an index. But graduated circle, graduated ring or card. So in the prismatic compass, you can see that graduated ring is attached with a needle, and it does not rotate along with the line of sight. So, and also the graduates or in WCB systems having 0 degree at south, 90 degree at west, 180 degree at north, and 270 degree in the east. So the graduations are uh, inverted. It's the inverted. And also, so when it comes to the surveyor compass, the graduated ring is attached to the box and not to the needle, right? And this rotate, and this will rotate along with the line of sight. Okay, and there are quadrant, graduation or in quadrangle bearing QB systems are 0 to 0 at north, and so 90 at south, and east west are interchangeable. Okay, and this also graduations are erected. Okay, and the sighting van in both the prismatic and in surveying compass totally different. The object van consists of a metal with a van of vertical hair, whereas in the object van consists of the metal van is with a vertical. Both are the same. So I van consists of small metal with a van of slate. It's also same here. And most of the things are same, but there are relative functioning will be the different, operational will be the different. So reading of the systems, readings are taken with the help of prisms provided with the isolates. Sighting and reading can be done simultaneously from one position to one position of the observer. And also the readings are taken by the directly seeing through the top of the glasses. And here's the tripod, and so here tripod may be used, may not be used. If you put it, an instrument may be even you can hold it in hand. It's a handy. Okay, and the instrument cannot be used without tripod. So in the surveyor compass, you must have the tripod. Without tripod, you cannot use the this surveyor compass, right? So the main objective of surveying is to, the surveying is to prepare the map or a plan to show the relative position of the objects on the surface of the earth, right? So map is drawn to some suitable scales. It also shows the boundaries, the different types of the different boundaries, like district, states, and countries boundaries, and it also includes detail of different engineering features such as buildings, roads, railways, and also the dam and canals, right? Yeah, in the especially in the compass surveying, there will be bearing that we have discussed there. Conversion, you can see that there will be a system of bearing, whole circle bearing, a reduced bearing, fore bearing, back bearing. Right? Those things they are going to have this. This is how it looks. The prismatic compass. Right here, you can see this. East, west, and north, south. So always it shows the north wherever you stand on that. This is measure the graduated circles which covers the degrees, and inside there is another circle. Okay. Right, and here is the part of the prismatic the compass, and which is having the screws, and where we are going to set with a tripod. Okay, circular metal box which is 10 centimeter, okay, 8 to 10 centimeter dia. Okay, and here is the focusing with eyes, eye van, guide van this here, and there are bubble tube which are standing for especially for the leveling purpose, and also there will be a magnetic needle here inside that, and it's a fixed graduated plane. Bottom is a fixed graduated plane, you can see that. These are all the typical parts of the prismatic compass and survey compass, prismatic compass, which are a test count little bit variations technology wise, and also the difficulties. What are the components? Just now we discussed that is in the things, and here is the completely cross sectional views, right? And prismatic compass magnetic needle attached to the circular. This all those things. So magnetic needle, it's the heart of the instruments. Without needle you can't get any the bearings, right? And of course you can get the bearings, but it's very difficult to assess, and you'll not get the exactly one. Magnetic needle is the heart of the instrument, and this needle measures angle of line from the what you call this magnetic meridian at a needle. Okay, it's always remains pointed towards the north, and south pole at the two ends of the needle. Okay, when it's freely suspended at any support. Okay, that shows always the north south. Okay, then you set your the directions. So the graduated circle, this will be have 0 to 360 degree aluminum graduated ring, which is marked 360 to 0 to 360 degree to measure the possible bearing of lines. Okay, and attached with a magnetic needle, the ring is half degrees. Right. How we are going to adjust it, that we discussed just now. Centering. Okay, centering is the most important. Centering is the operation in which the compass is kept exactly over the stations. Okay, where the bearing is to be determined. Right. That mark has to be done in the ground. So the centering is checked with a checked by the dropping of small pebble from the underside of the compass, or you can do it use it as a plumb bob. That is the best one. That will give the accurate results. The if you leave the stone from the prismatic compass to the bottom, it may divert, or while leaving the small stone, it will be it gives some errors. Okay, better to better you avoid those throwing the stones and all. Use the plumb knob. Okay, that will give the exact results. Okay, and if the pebbles falls on the top of the peg, then the centering will be the correct, and if not, the centering is to be corrected by adjusting the legs of the tripod. That is the centering part. When it comes to the leveling of the compass is done with a freely swing of the graduated circle inside in the prismatic compass. Okay, and this can be actually in the ball and socket arrangement in the tripod, which will help in the achieve the proper leveling, and this can be checked by the rolling of the pencil or covers. So how we are going to focus it? The prism is moved up and down in its slide till the graduations on the aluminum ring, and clear and sharp and perfect focusing must be done. Okay, the focusing of the prism will depend upon the vision of the observer. That is a thing. Yeah, this is all about what we discussed now, right? and how this is how the the prismatic compass fixed on the tripod. Okay, and here is the suspended freely. Okay, when you want to make it measure properly here, the centering to leave the stone from the centering of this instrument, and wherever it was, that is your mark of this particular point. Otherwise, you can put the plumb knob for this. Okay, right. And here is the bearings. As I told you that the bearings, or you can take it as a whole circle bearing, or you can take it as a quadrangles. All right. So here is a okay 0, 90, 180, 260, and 360. Sorry, 270, 360. 360, 0 at the same place. It is always showing the north south direction, the needle, red needle, and wherever you want to focus, you can focus it, and then north 10-degree west, north 45-degree east, north 45-degree east, north 80-degree east, as much as if it is a north 10-degree means where east means this is the direction you will get it. North 80-degree, you will get the direction like this. If it is a, you can do such a way that north 285-degree, only whole circle bearing. If you take it whole circle bearing, it gives the north 280. It will come like this. North 280, just that's it. That's a whole circle bearing reading. If you are taking the quadrangle, here you can see this north 10-degree. Okay, here you can see this north 10-degree east. Okay, south 10-degree west. This is how you can read it, or you can north 175-degree. That's all. So it will come directly here. Otherwise, south 25-degree east, north whatever the 25-degree west. That's how the quadrangles readings you can take it. Yeah, here is the you can see this. This is angle of inclination of the angle of your the directions. Okay, that's the things. So intersection methods to plot the given areas using the compass. You need a compass, prismatic compass, tripod, and also the chain, tape, and arrows, and the readings. So here is the thing, son. AB is the the surveying line, and you can establish with by using the prismatic compass and the tape. Also, you need the tape actually. Without tape and chain, you cannot you need the ranging arrows and ranging rod. Okay, otherwise it's very difficult measure the distance, mark it on the surface of the ground. So you can, what is the angle here? You can check it. This is your north and it's a 0. Okay. So when you fix the compass here and you want to mark this point, what is the angle of it's angle from this point? It's just I think it's a 5 degrees or 8 degrees from the north. So mark it and measure with the horizontal distance using the tape or maybe the chain. That is up to you. Okay, this is a one mark. From here you can do this, or from the here you can establish this, and you can focus from A to Q so that you will get the angle of for this. So this is how you can establish the geometrical figures. Right here you can see that every way there will be triangles. Okay, right. Yeah, this is a one what we seen there. A, B, Q, A, B, and PQs. Right. This distance. T1 and yeah, here is the small d distance. These are the distance from B to BQ and AB. Sorry, AP, D1 and PQ is the D1 here. And these are all the the entire area is divided into 1, 2, 3, 4, 4 triangles. Okay, that will be angles. You can get the angles. So this will give the more accuracy for calculation of volumes, and this type of work it can generally happens with any softwares when you are going to use the 3D modelings. Okay, and here is the the pond. Generally, what will do be A, B, C, D, E, and this is a pond areas which you need to survey it by the compass. Easily you can do it. Fix the first point here, then you need to move towards this side, and how much is the distance, measure with the tape or compass, right? And what is the bearing here? This is, if this is a north, it's almost 45 to 50 degree east. So just to mark it, then from here you can look at this point C. From here, if you are looking at, this will be the, your north. Whether you can take the whole circle bearing, yes, north. This is almost 90 here, okay, north 90 degree. Or you can do it as a, if it is a, more than 90, it's a 1 knot. So north 100 degree. This is a whole circle bearings. If you want to take it south, north 10 degree here, south 90 degree here. This is how otherwise you can do it. So whole circle bearing or quadrangle bearing. That's how the things. This is how you need to set the, the geometrical, the figures. It's a triangle, okay, and it's a rectangles, okay. You can make those things. And yeah, here is, bearings, what we line of sight objects, vent, and prism shield eyes. And here inside is the graduated circle or the rings, okay, right. And here how we are going to start the survey and end with this. And when you are taking the turn, you have to take the bearings first, okay, then you move with the next point. Start with this point, and this is your actual the north, okay. And how much is this towards this side? It's maybe the 10 degree or it may be the 15 degree north, 15 degree east, okay. From here you can mark this place, okay, and measure the distance with the tape. And again, the area is towards this side, and which side? That's a northwest side. This is a north and it's a west, northwest side. What is this? It's almost 45 degree north, 45 degree west, and south 45 degree east. So just to mark it there, and again you can take it. This is how we need to do the survey of prismatic compass. And you can construct any the geometrical figures, right? That is your convenient. As per your convenient, you can do the polygons, sorry, you can do the rectangle, triangle, or it may be the like square. So the convenient, as per your convenient, you can complete the survey and do the evaluation there, right? So these are all the the prismatic compass, which is using the prismatic compass, and especially for the measuring the bearings. So let's what we'll have this with this. So in the last class we discussed about the field, especially with the field where we are using this prismatic compass necessary. It's a table we are not using here. Dumpy level, auto level, yes. Where there is rising of pipes, high rise pipelines, okay, that areas we are using those things. Let me show you something now. Yeah. Yeah. Here is the tripod. So the slope or rocky areas, it's a little bit difficult to set up this. Okay, you should take care of this prismatic compass. It may, once you fall down, definitely it will go down. It's not a ranging rod. It's not staff readings. Okay, it's it's made with the glass. Okay, definitely it will be break it. Okay, this is how you need to set up the the ranging the tripod, and you can focus it with the van, and you can, there will be one called the focusing line here, and through this you can see this, and you can take the readings of this, right? That's a very simple one. And yeah, you can easily set out this the field itself. No, nobody is using here. Yeah. No, we are not using here. Oh, that is, spreading. Okay. Akshay, the slides are visible. Alakya?
Yes, sir, Devastar.
Okay.
Yes, sir.
I'm searching for a very good the compass so that you can. Yeah. Let me show something now. Show some of the. It's called. So very good. Some of the very good photos. Actually, I'm not sure where this exactly. Let me show you some of the very good the compass photos, so that you can survey. Earlier, they used to do the only the compass survey because they don't have the total session and all, so that accuracy we had to take care a lot in that case. Okay, all right. Let me show you some of the fish survey. Survey. Okay. Let me check with this on the photos. There are very good photos of no. Right, that's so difficult to get the photos. Yeah, this is these are all about the the what do you call this measurement of horizon, the bearings. Okay, measuring the the bearings using the compass, right? And yeah, you can do the survey, right? And generally the compass with the the tape or the what you call this your chain, These are the three equipments. If you want to, the what you call this tripod, you can take it. So chain survey and tape survey, and also with the compass. These are together always, right? And also with the plane table surveys, right? So, I missed there. No, they don't have the survey here. Dumpy level, auto level, yeah. So most of the place we use the auto level or dumpy level for the survey. For main, for the the town planning, and also for the the highway, we use especially the total station survey. And for the the water supply, and also for the high rise pipelines. So for those purpose we use the for better practice we use the compass, as well as the the chain survey. Really, we are not going to for the chain survey because carrying is the problem. So we used to take the what you call this tape and compass surveys. Okay, the compass survey is very fast for taking the bearings than your what you call the plane table surveys. So here in the plane table surveys, it's very difficult part, and I mean it takes time to taking the readings and taking the the set up the things actually. Okay, right, where we had that plane table survey, that takes a little bit time. We can see this. So how they are set up, the prismatic compass. So it's difficult for them, especially in the slope areas. Okay, and in the flat land you can easily set up the things, right? And here you can see the prismatic compass. Sorry, the prism. Okay, right. What I can show the table. Plane table survey. Oh yeah, yeah. Set up this plane table survey is setup is a very difficult. See here you can see this plumb knob. Every plane table survey there will be a plumb knob. Without this is very difficult. Otherwise, the your directions and your the leveling will be the wrong. So here is each and every plane table there is a plumb knob. Here you can see this. Okay, and every time when you change the instrument, change the location, change the stations, so your what you call this you have to set up with the all the tripods and the centering, and you have to set up with the leveling with the the bubbles. Okay, this take another the 5 to 10 minutes to set up this. So for what you call this your compass survey, it takes faster than this. Same thing. Okay, and alignment taking is very difficult, and drawing is very difficult. eh? But you have to do it, and we'll do it. So just it will give you from the practice itself. So here is a one more plane table survey. So within a span of time, many of plane tables, the you can see this. And many the survey team was arrived here. That's why this you can see this double level, right? Yeah, yes, so this, right. Okay, right. Yeah, yes, yeah. Okay, this is all about the the prismatic compass survey, and also the what you call this how we are going to take the bearings, and how we are going to what you call this make the geometrical figures for calculation point of view. So let me show you some of the, what you call this, how the, what is this, especially the digital terrain models and how digital terrain model determine now data input, so that you will understand how it is, what is this determine now. So all text, especially for the replacement bar holes, and this is actually we did for the, the mining areas, especially the uh, borehole plotting, getting the, borehole editing, wireframe model. Yeah, I think here you get the, your AutoCAD can do the same work way. Yeah. So here, you can see this. So these are all, boreholes, and before this, borehole plotting. So how the, 3D model you can generate, what we call it is exactly. Yeah. So these are all the, the surface points when you survey it, either by GPS or maybe the total section or maybe the dumpy level. Okay. So these are all the, surface points, means maybe any object, or it may be any the survey location, or it may be a station, or it may be any the trees, or it may be any benchmark. This is a surface points. From this is actually what we surveyed. We surveyed for the boreholes. These are all the drilled boreholes for exploration point of view. How we are going to construct, how we are going to, to do the, what you call this, uh, terrain modeling or block modeling, or maybe the, wireframe modelings. All these things are, you can see this surface, the top, you can see it here. Okay, this is just borehole plotting. Just we are plotting the boreholes. You can see that here. Okay, and the next one is that. So you can do some editing part here. Yes, borehole editing part. It's generally it automatically connects with the, yeah. This is a, editing part. It just works as your AutoCAD or SketchUp. Okay, and these are the boreholes depth, different depth. What we are going to get it here. Okay, and yeah, give the, different the colors for different lithologies. Okay, and yeah, here you can see this. So 0 to 5 meter, one lithology in different formations. For all these boreholes, we are going to do the cross sections, and we are going to do the 3D modeling for this, and that you takes you the triangular irregular networks, triangulation internet and interregular network. That's called a tin. We call it as a tin, and also we call it as a DTM, digital terrain model. Also we can call it as, that's another one. Okay, that is a best example. We can I would say it's, because I don't have the, the CAD here. It's very difficult to look at this. Yeah, here you can see this, and this is a well surveyed data, uh, and how you are going to connect with this. These are the surface data. Okay. This is actually the pit bottom of that, and this is the surface. and this is the data surveyed from the GPS actually, right? This is served from the GPS, and same thing you can do it with your total session, auto level, or dumbbell levels. Any instrument you can use it. Okay, all right. It works like the contours, and with the contours and other over body contacts, waist contacts. So all those things we are going to plot it here. Yes, borehole locations. Yeah, we plot. We just plot the boreholes here. The contours. Okay. And we are going to develop the wireframe, that is with the triangular one. Yes. Can you see this? Anywhere, if you see, can you see anywhere in the rectangle or something else? Everywhere there will be a triangular only. That's why we call it as an TIN, triangular interconnected network. Look at this. This is called a block model. We call it as a block models. Okay. And each block and each cell, what is the area is required, the everything we need to give the inputs for that, so that it will calculate easily for that. So we are going to evaluate it. Listen us. Now I am going to change the things. So finally, how it's going to be. This is just like a sky, but it's I'll show you the photos of that, especially is this mine pit. Yeah, create a DTM, digital terrain model. Now it looks like this. How it's very easy to make the database. Yeah, it is connecting almost all the area what we have selected here, and selected of ore body and the contours particularly. Okay. The drill holes. All right. Come on. Yes, yes. So what is this? That's called wireframe triangular. Yeah. This is called a terrain model. Only the terrains, the surface of the body, surface of the mines. It's not showing the subsurface now. It's the surface. What is looking that? That's called a terrain model. Right. This is the pit bottoms, and these are the contours that is surveyed, the elevations. Okay. And so the entire area is the surface area is divided by with geometrical figures. That's called only the triangle, only the triangles, no square, no cubes, no rectangular. So only square. So only the triangles only takes. Okay. Into the block leveling, block level modeling, digital terrain modeling, right? Yeah. So with this, that's what we see in that. That's a wireframe modeling. Yes, it's almost the same. This is how they know the, yeah. And for especially what will you can nothing for GS in 3D models, the exercise, database, the analyst, the raster data, no. So almost all the softwares working with the same, what you call this thing, but with concept, the requirement will be the different, concept is the same there. GS training, data mine files, okay. So database, no. Oh, let's throw data, say, come on. All right. So what we are going to demo model, digital elevation models. How we are going to generate the digital elevation model? No. We have to create ourselves. Yeah, so preparing the arc map. Searching for, yes. I said that this is a tin actually, and that's called a triangular integrals. So image is not clear, I think. Yeah. So quality is not clear. How to create the contours, hydraulics.
Welcome everyone to a new tutorial in the
Yeah. Okay. This should be the better. Yeah. How they are going to create the tin triangular interconnect network. Okay. And this is the the image which is collected with a raster image, and which you use it for watershed analysis. Okay. Raster to the the tin. I don't think so. This clear. The text are not clear here. No. That's how it's going to process it. Yeah. Yes. Yeah. Yes. Yeah, this is how I know the showing the triangular interconnected network. This is how it's showing the arc scene. Somewhere we call it as an arc scene. So from the aerial view. The complete area is, the block modeling, interconnected, and digital terrain model. This is how it looks when you did the map, right? All right. So the other things are with block modeling. Okay. So this is how the what you call this softwares. Okay. Right. Yes, these are all the things what I showed you, and so this is all about the today's class. So in the next class, we'll go with different experiments. So when you are in the college, and we will have the all these experiments, and this is a theory part which you can finish it now, right? Akshay, Alakya.
Yes, sir.